Now this curve has quite a geometric shape. It's kind of a semicircle and a line there. So to make it a bit more organic, we're going to add some noise to it to move the points around. So there are many different ways to do this. In the previous week, in week 3, we used those mountain nodes to work on the ground, which you could do here as well. We're going to do it now with a point swap. Okay, and in this way we're going to have a bit more control with the point swap. So we're going to be taking the position and exporting the position back out again. So here I'm taking the attributes and writing it out exactly the same. You know, I'm not doing anything to it. We can use a turbulent noise. Okay, so with the turbulent noise, we're working in 3 dimensions here, where we have a vector. So we need to change this to 3D noise. If we connect the position, let's see if this does anything. And there we go, we get this really weird messed up line. So this turbulent noise has no correlation to the noise before. So what we can do is if we take an add, okay, we take the current position and add the turbulent noise position to that, and then plug that back in, and then we get something a bit closer to what we want. What I'd like to do is only move the points in one direction. Okay, only in Y. So I need to separate. So here I've got a vector, the position, which is X, Y, and Z, and they're all together. So I need a way to split that to keep X and Z separate, apply some noise to Y, and then bring them all back together. Okay, so how we do that is to use a vector to float. So I'm going to take a vector to float, drop it up here, so that you can see we connect the vector, and then we have access to X, Y, and Z. And then here, actually we apply the noise to all axes, but we don't use them all. And then we take another vector to float, to take the result from here. So now we can take the Y from here and the X and Z from there, but we need to connect it to the position here, which is a vector. So we need to convert these back into a vector. So we need a not vector to float, but float to vector there. Okay, so we take X, connect it to X, Z, oh, not there, Z, and connect it to Z, and take the Y and connect that up, and take that vector, connect it to P. And there we go. There's our results at the moment. So you can see now that the points are only being transformed. If we turn on the point view, maybe if I go back here and go to this bypass, which will turn off the node, you see the points are only moving up and down. Okay, so we have more control here in the point VOP for different types of noise. Okay, they're not moving in this direction, in the Z or the X, right? Great. So now to kind of fine tune this noise, if we come here to the turbulent noise, I think we did this in week 1 actually, I'm not sure. A common practice, so you can change these values here, but it's nice to have everything in one area. So you build the emitter here and have access to all the parameters. Also, I believe, if you want to add animation, it needs to be in this at this level. I'm sure in the past I've tried to animate. We could try right now just to test it. So let's see, we could do the, I don't know, the offset, right? So if you change the offset, you get this. If I put $F there, So this will equate to the frame number. See there we got 12, we got 12 there, but nothing's actually happening here. When I play that, it's static. If I turn on the real-time toggle, so it doesn't fly through. So if I right-click, delete channels, and then just on the offset for the moment, if you middle-click, promote parameter, you get this tab, which basically is, if you double-click, it makes this for you. It creates a new parameter, but by default, it drops it here, offset. So now, if I put $F, we should see the animation. Okay, so that's kind of something that kind of annoyed me in the past when I didn't understand why it wasn't working on the inside the VOP, but you know, now you know. So we'll delete that. I don't want animation on this, but I'm going to go back inside and then do the same for the rest. So middle click, promote parameter, amplitude as well, the roughness, attenuation, and turbulence, why not? All of them. Okay, so we got access to everything out here now. So the values, let's see, so the amplitude, if you remember from week 3, it's kind of how high, how big the noise is. Put that to 2. Roughness, kind of self-explanatory, how sharp the points are. Yeah. Let's drop that down. Put that about. I've got 8.52 value I want to use there. Attenuation, and then turbulence, kind of how wild, crazy it is, you know. Take that right down. I just want something really subtle here. Let's see. And frequency is how often we see a change, right? So if we go down, we'll have something smoother. See? If I go up, you get a lot more. Down, get something smoother, calmer. And then the offset, I'm just gonna put that back to 0. Just kind of can scroll through this, and this, you know, all of these values are the same. The noise is the same. It's just the location of the noise. So we'll find some different values. Let's try. I got this in mind there. Okay, so it's quite subtle. Let's try negative. Whoops, not multiplied. Negative 5.8. So yeah, it's quite a subtle difference, but it will help. You know, when you're building emitters, it's almost more important than what you do in the DOP network, in the dynamic network. The emitter has a very big effect on the look of your fluid. Okay, so you need to spend a lot of time working on these shapes and experimenting with different things to see what you get.